Hey, what's going on, guys? In this video we are going to see how to find the Laplace inverse of s over s square plus 8s plus 19. Now first of all, you have to see whether you can factor the denominator. Here this denominator is not factorable, so we can complete the square and then we do the factor. So if we complete the square, this is going to be, here we have s square plus 8s plus 19, and to complete the square what we do is we know that if we divide the middle part, that one by 4, actually by 2, this is our b by 2, that's 4. So we have to have 16 4 square, b square has to be in the at the end, so we have to have 16 in order to get the complete square. To get 16, what we can do, here we have 19. To get 16, if we subtract 3 and add 3, subtract 3 and add 3, then it's going to be in a complete square form. Like we can write it as s square plus 8s plus 16 plus 3, and here this one is a factor of s plus 4 square plus 3. Now we have a factor, so we can write this one like this. Okay, now let's go ahead and complete this one. So this is going to become Laplace inverse of s over, instead of this I write this one s plus 4 square plus 3. Now from this one, let's see what we can do. Here we have e power at cos 3t pattern, because in e power at cos 3t, Laplace of e power at cos 3t is equivalent to s minus a, we have to have s minus a in the numerator and has to have s minus a square in the denominator plus b square. Now here we have s over that pattern, kind of that pattern, so but we don't have s minus a. Here we have s minus a as s plus 4, so we have to have the same thing in the numerator. To get the same thing, what we can do is we can add and subtract 4. If we do that, this is going to become Laplace inverse of s plus 4. If I add 4, I have to subtract 4 because we are adding something that does not exist, so we have to subtract that one as well. And the numerator remains the same, s plus 4 whole square plus 3. Now until this term, this is e power at cos 3t pattern, but this minus 4 doesn't belong to this equation, so we have to separate this one. But this minus 4 also contains the denominator, so we have to bring the denominator as well. So if we write the Laplace inverse, this is going to become Laplace inverse of s plus 4 over s plus 4 whole square, and instead of 3 I put square root of 3 square, okay, plus, actually minus here, minus, and I bring the negative 4 to next thing because negative 4 is not needed for e power at cos t. So negative 4 over s plus 4 whole square plus 3. Okay, now this one is in sin bt pattern, like same as Laplace of e power at cos t is s minus a over s minus a square b square. There's another formula for sine. Sine is Laplace, okay, Laplace of e power at sin t. Sin t is basically b over s minus a square plus b square. Here we have to have b in the numerator. B is square root of 3. So this is, here we have square root of 3 square as a factor, because same thing here, because 3 can be written as square root of 3 square. So b is square root of 3. That's what we have to have in the numerator. So we have to get, here also we have Laplace inverse, and we have to have the square root of 3 in the numerator. To get square root of 3 in the numerator, what we can do is we can multiply and divide square root of 3, and also we have to get rid of this 4, so I put the 4 in front. So if we rewrite this one, this is going to become Laplace inverse of, for this one we can straightly write it right now because it's already in full format. Here this is e power at cos 3b cos bt. E power at, a is what? A is s minus a. The pattern is s minus a, so minus 4. Minus 4 is the a. Minus 4t cos bt, cos, and b in our case square root of 3. Square root of 3t minus, and first let's rearrange this one and write it in a better way, then we can clearly see the transformation. So for Laplace inverse of, here we have 1 s plus 4 square plus square root of 3 square. As I mentioned before, we had to have b in the numerator. So to get b, we had to multiply this one by square root of 3. Since we are multiplying something that does not exist, we have to divide that one as well. So I put the square root of 3 in the denominator at the front because it's not needed here. So I put this one. Now we can convert this one into sine 3 bt because we have this one in b over s minus a square plus b square pattern. So we can convert this one into sine format. So if we convert, this going to become e power minus 40 cos square root of 3t minus 4 over square root of 3 Laplace inverse of, okay, we don't have to write the Laplace inverse. Now we can directly write the inverse. The inverse is e power at. A is minus 4 again, minus 4t, and sine bt, b is square root of 3t, and that's our final answer. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe this channel. See you next time.